Hi everyone, I'm about to start on the solution set for the binomial expansion problem package. So follow along with me and we'll basically find the solutions for the entire package. You don't have to do every question, but my suggestion once again is to do every question so that you can get better at it. Alright, so number one, use the binomial theorem to complete this expansion. So 3x plus 2y to the power of 4. So I'm just going to write this here. So it's 3x plus 2y to the power of 4. So if you recall, we always start with an index of 0. So actually I'm going to use a different color for this last one. So let me start with black. So it's equal to 4, choose 0, 3x to the power of 4, and 2y to the power of 0. And basically they've given us the first term already, so this should evaluate to 81 to the x to the power of 4. But I just want to write it out so that it's clear. The second term is 4, choose 1, 3x, 2y, 3x because that's the first term here, 2y, and the power here should be 3 because it's 1 less than the previous one, and the power should be 1 because it should increase by 1. And if you evaluate that, then you should get 216 x cubed, x cubed y actually. So let's do the last three terms of this expansion. So it's 4, choose 2, 3x to the power squared times 2y squared. This, remember, 3x decreases in power and 2y increases in power. Let's do the last two. So it's 4, choose 3, 3x to the power of 1, 2y to the power of 3, and finally it's 4, choose 4, 3x to the power of 0, and 2y to the power of 4. So if basically since we've done the first term and the second term, I'm just going to evaluate the last three. So I'm just going to say dot 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 plus because the dot 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 covers the first two terms. So this will be 4. Sorry, this is 4, choose 2. So I believe that's 6. Yes, that's 6. So it's 6 times 3x squared is 9x squared, and 2y squared is 4y squared. So that's this term done. The next one is 4, choose 3, so that's 4. 3x to the power of 1 is simply 3x, and 2y cubed is simply 8y cubed. The last term is 4, choose 4, so that's 1. 3x to the power of 0, that's also 1. And 2y to the power of 4, it's 16y to the power of 4. So if we expand it, I'm just going to put dot 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 to represent the first two terms. So 9 times 6 is 54, and 54 times 4 should be 216. Yeah, okay. Yeah, 216 x squared y squared. So note how this is different from this one. This is 216 x cubed y. It just turns out we have the same coefficient, but now our variables are x squared, y squared. This is 4 times 3 times 8, so this is 12 times 8, which I believe is 96. Yes, so 96x, because the x over here, and y cubed, so it's x y cubed. And finally, the last term is 1 times 16 y to the power 4, so 16y to the power 4, and that's the completion of number 1. So number 1, the last three terms are 216 x squared y squared, 96 x y cubed, plus 16 y to the power of 4. Okay, so I'm just going to erase this because I just need a little bit more space to do the other questions, but we can, here. So I'm just going to erase this. So you can always scroll back to the video and figure out how I did number 1, and that's the solution for number 1. All right, so moving on to number 2. Complete the following expansion. So 2 plus ax to the power of 4. So same thing. It's very similar to that one. So we have the first two terms. So remember, the index for this one is 0. The index for this one is 1. So the index for the second one, for the third term would be 4, choose 2. 2 to the power, and let's just do this, ax. So this will be squared, this will be squared. So remember, this term here is always the same as the exponent in the last term over here. So 2 over here, same as 2 over there. So plus 4, choose 3, 2 ax. So this is going to be 3 here, and that's going to be 1. And let's do the last one, which is plus 4, choose 4, 2 to the power of 0, and ax to the power of 4. It's a little squished there, but anyways. So 4 choose 2 is 6, 2 squared is 4, and ax squared is a squared x squared. Plus 4 choose 3 is 4, 2 to the power 1 is 2, and this is a cubed x cubed. And finally the last one is 1, 4 choose 4 is 1, 2 to the power of 0 is also 1, and it's a to the power of 4, x to the power of 4. So, oops, what I should have done is instead of putting equals, I should have once again put equals to dot 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 plus, and the dot 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 would just have represented the 16 plus 32ax. So I'm just going to follow this here. So it's equal to dot 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 plus 6 times 4 is 24. It's 24a squared x squared. This is 4 times 2 is 8. So 8a cubed x cubed. And finally the last term is a to the power of 4 x to the power of 4. So that's our solution for number 2. Okay, so once again, I just need room to do the other questions, so I'm just going to erase this, but you can always scroll back in the video to see how I did that solution. Okay, number 3. Consider the expansion x squared minus 2 and that whole thing to the power of 5. Write down the number of terms in this expansion. So if you notice that, for example, when we had, now I should have written this down, but when we had this one, we had the first 2 and then we had 3 more terms. So we had 3 more terms following. And same thing with this. When we had this one, we had 3 more terms following. So in other words, when you have the power to the 4, you actually have 5 terms because you start with an index of 0. So 0, 1, 2, 3, 4. So when you count from 0 to 4, it's actually 5 terms. Same thing here. We start with an index of 0 and this index of 1. So 2, 3, 4. So when it's from 0 to 4, there are actually 5 terms. So in other words, the number of terms is always the power plus 1. So consider the expansion, so write down the number of terms in the expansion. Without even like doing it, we can already say that it's actually 6 terms because it's to the power of 5, and 5 plus 1, that's 6 terms. Okay, the first 4 terms of this expansion are in descending powers of x are, okay, so there we go, so that's where we have the descending powers. Find the value of a. So a is the coefficient of x to the power of 4. So let's sort of figure out what a is. So one of the terms will be like this, right? Where it's to the power 5 over here, we have x squared over here, and then we have negative 2 over here. Now what we want is to the power of 4. So since x squared is the only variable here, we need a number over here, an exponent over here, such that x squared times that will be x to the power of 4. So the only number that can do that is 2. And if that's 2, remember this exponent here must add up to that exponent there to equal 5. So this will be 3. And therefore, since that is 3, this is also 3. So now we just have to figure out what this is equal to. So 5 choose 3, I believe that's 10. 0, 5, 10, yes. So 5 choose 3 is 10. And this is x to the power of 4. And this is negative 2 to the power of 3, so that's negative 8. So in other words, this is equal to negative 80x to the power of 4. And that's our solution. So that's the value of a, and we have 6 terms there. Oh, sorry, so the value of a, so a is therefore equal to negative 80. And that's our value. Okay, so let's move on to number 4. So consider the expansion x plus 2 to the power of 11. Write down the number of terms in this expansion. As I explained previously in the previous question, if our exponent is a certain number, the number of terms will be 1 plus that exponent. So since our exponent is 11, the number of terms here will be 12. And it also says write down, so it's a pretty simple question, so we're done with that. Find the term containing x squared. Okay, so straightforward once again. Let's do our choose term and our 2 terms. So this is going to be 11. The first term is x and the second term is 2. We want an exponent of 2 because we're looking for x squared. So in other words, the exponent here has to be 2, and if that is 2, then this must be 9 because 9 plus 2, or 2 plus 9 is 11. So if that's 9, so is this. And let me change colors here. Okay, so 11 choose 9. Now I actually have to use the calculator for this one. So 11, let me just see here. 11, I'm just using my calculator right now. 11 choose 9. That's 55. Oops, here. So that's 55. X squared is simply x squared times 2 to the power of 9. 2 to the power of 9. That's 512. So it's 55x squared times 512. And so what that is equal to is 512 times 55, which is 28160 x squared. And so that's the solution for B. All right, let's move on. Let's do this one. Find the x cubed term in the expansion of that. So same deal as before. So we're going to have a choose term. This is our first term. This is our second term. It's going to start with 8 because we have a power of 8. This is going to be 2/3 x, and this is going to be -3, right? So the power that we want over here is, since we're looking for the x cubed term, obviously since this is x, this has to be 3. And if that's going to be 3, then this is going to be 5, simply because 3 plus 5 must equal 8. So if that's 5, then so is this. This is also 5, because remember the second exponent over there is equal to the r term over here. And let's just do this. So I will definitely need a calculator, so I'm just going to use that right now. So to find out 8 choose 5, that is 56. That's 56. This is going to be 2 cubed. So 2 cubed is equal to 8x cubed over 27, because 2 cubed is 8, x cubed is x cubed, and 3 cubed is 27. And then -3 to the power of 5 is -243, -243. And so if I just basically plug this into a calculator and try to simplify it, so 56 times 8 times -243 divided by 27 actually gives me -4032 x cubed. And that's our x cubed term for number 5. So we're done with number 5. All right, so number 6. Let's start over here. So consider the expansion of the expression x cubed minus 3x to the power of 6. Write down the number of terms in this expansion. So as we've already discussed, when the power is 6, remember our index starts from 0. So 0, 1, 2, 3, 4, 5, 6 is actually 7 terms. So we actually have 7 terms over here. Now find the term in x to the power of 12. So whenever we have like 2 variables, it's really a good idea to sort of write a table to see how this would go. So for example, so when we write the choose terms, we always write the 3 terms, right? This is to the power of 6, so it'd be 6 here. The first term is x cubed. The second term is -3x. I'm just going to sort of rewrite it just so we have a bit more room. Yeah, I put them a little too closely. So let me just write that again. Right, so there and there. So it's going to be 6. This is going to be x cubed, and this is going to be -3x. Now we have to decide what these exponents will be and what the right exponent will be in order to get x to the power of 12. So let me make a little table here. So this is going to be the x cubed table, and this is going to be the -3x. And really what we want to make sure is that the exponents, this exponent plus that exponent, they add up to 12, which is what we want. So say for example, I'll write this in black. So say for example, we choose r equals 0. So if this is equal to 0, that's equal to 0, and this will be equal to 6. So let's say r equals 0. So when r equals 0, 3 times 6 in this case will be 18, and 1 times 0 will be 0, and 18 plus 0 is not 12, so we're not going to have that. Let's next try r equals 1. So if we have r equals 1, so let's sort of do that here. So if r equals 1, so that's 1 over here, and then that's 5 over there. So r equals 1, so then that's going to be 15, and that's going to be 1. obviously that doesn't work because 5 plus 1 is 16. So if let me just do r equals 2, and then basically we'll see sort of a pattern develop, and then we'll just go from there. So if r equals 2, this is equal to 2, and that's going to be 4. It's 4 because, remember, 4 plus 2 is equal to 6. So now the exponent here will be 3 times 4, which is, so this is r equals 2. So this will be 12, and this number here will be 2. But 12 plus 2 doesn't work because we want 12. So if you observe what's happening is 18, 15, 12. So in other words, this is dropping by 3 each time, whereas in the other column, it's increasing by 1 each time. So if I do r equals 3, without even having to sort of punch this in, I already know that this is going to be 9, and this is going to be 3. So because you can see that pattern developing, and 9 plus 3 is 12, so definitely r is equal to 3. So let's change that and figure out what that's going to equal. So this is going to be r equals 3, that's going to be 3, and that's going to be, sorry, if that's 3, then this is also 3. And as you see, we can get the 9 because 3 times 3 is 9, and 1 times 3 is 3. So that's how we get that. So if we basically expand this, so 6 choose 3, I'm just going to sort of do that in my calculator right now. 6 choose 3, and that's equal to 20. So it's equal to 20 times, this is x to the power of 9, right? And this is negative 3 to the power of 3, which is negative 27 x cubed, right? So this x to the power of 9 and this x cubed, those exponents will add up to 12. So it'll be 20 times 27. So that's equal to negative 540 x to the power of 12, right? So the term that we want here, to find the term, it's simply negative 540 x to the power of 12. And remember, the time when we use this table is when you have a variable in the first term and a variable in the second term. If you only have a variable in the first term, you don't need the table, okay? So let's just, I'm just going to erase this so you can always scroll back and see how I did this problem, all right? And because I need the room for number 7 and the other questions. All right, so one of the terms in the expansion of x plus 2y to the power of 10 is ax to the power of 8 y squared. Find the value of a. All right. So once again, it's pretty straightforward. We just do this 3 terms right here, right? This is obviously going to be 10 because it's to the power of 10. The first term is x, and the second term is 2y. All right. So now we want x to the power of 8. So what number can I have in order to have x to the power of 8? Well, it's going to be 8. And what number? Obviously, this has to be 2 because 8 plus 2 is equal to 12. And that makes sense because you have x to the power of 8 and you have y squared. So if this is 2, then that makes this 2 as well. So let's find a. So what this means is 10 choose 2. I'm just doing that on my calculator again. So 10 choose 2 is 45. Oops, let me just do that. So that's 45 times x to the power of 8. And then this is 2y squared, so that's 4y squared. And what that is equal to is 180 x to the power of 8 y squared. So what is the value of a? A is simply equal to 180. And we're done. So we've done number 7. All right, number 8. Find the term containing x to the power of 10 in the expansion of 5 plus 2x squared to the power of 7. Okay, it's the same deal as always. There's really nothing very different for all these questions. It's pretty much similar in almost any case. So in this case, this power is going to be 7. The first term will be 5, right? And the second term will be 2x squared. So it's 2x squared. Oops, nice, x squared. Now, the question is, we want x to the power of 10. So what power should, and this is a constant and this is a variable, so this is the only one we really have to deal with. So what power do I have to put in here in order for this x squared to become x to the power of 10? Well, it has to be 5, right? Because 2 times 5 is equal to 10. So if this is 5, then this number has to be 2, because remember, these two exponents have to add up to 7. So if that's 5, that's 2, and then the bottom is 5, because the second term, the exponent of the second term always follows the bottom term of the choose. So what is this equal to? I'm just going to plug this into my calculator. So 7 choose 5. 7 choose 5 is 21. So this is 21. 5 squared is 25, so that's times 25. And 2 to the power of 5, I believe that's 32. Yes, that is 32. It's equal times 32 times x to the power of 10, right? So now we have to just multiply these three terms together. So that's going to be 21 times 25 times 32. So that's equal to 16,800 x to the power of 10. And we're done. So the term containing that is 16,800 x to the power of 10. So we're good for number 8. All right, find the term containing x cubed in the expansion of that. So same deal as always, all right, 3 terms. So this is going to be x to the power of 8, so that's 8. The first term is going to be 2, and the second term is going to be negative 3x. All right, so we want the x cubed term. So if we want the x cubed term, this is pretty straightforward, right? Obviously, this number has to be 3 because this is 1 to the power of 3 is 3, and the second number has to be 5 because these two exponents have to add up to 8. And then finally, this number here is 3 because the number over here is the same as the last one over there. So let's just continue with that. So 8 choose 3 is 56. 56. 2 to the power of 5 is 32. And negative 3 to the power of 3 is negative 27x cubed, which is exactly what we want. And so 56 times 32 times negative 27 is negative 384 x cubed, and that's our solution right there. So we got number 9. All right, so find the coefficient x cubed in the expansion of 2 minus x to the power of 5. So, oh man, this is like becoming so repetitive and redundant, and you're going to get sick of it. But now that you know exactly what to do, so this is to the 5 over there because that's to the power of 5. The first term is going to be 2. The second term is going to be negative x, right? And we want the x cubed term. So obviously, this has to be 3, and that has to be 2 because 2 plus 3 is equal to 5. And remember, the term over here is equal to the exponent over there. So once again, let's just figure this out. So 5 choose 3 is equal to 10. It's equal to 10. 2 squared is 4. And this is going to be negative x cubed, right? Which is equal to negative 40x cubed. Just making sure that's right. 4, 10. Yeah, okay, so that's negative 40 cubed, and that's the answer for that one. Okay, let me just scroll up here so I have more room. So find the coefficient x to the power of 5 in the expansion of 3x minus 2 to the power of 8. Same deal as always. Same deal as always. So we get those 3. So this is to the power of 8, so that's going to be 8. This is 3x, and the second term is going to be negative 2. We want x to the power of 5. So obviously, if we want x to the power of 5, this power has to be 5 because 1 times 5 is 5. And this is going to be 3. And since that is 3, the last term is 3. So all we have to do now is just basically do 8 choose 3. So that's equal to 56. 3 to the power of 5 is 243. So that's basically 243 times x to the power of 5, because 3 to the power of 5 is 243. And then negative 2 cubed is simply negative 8. And so if we multiply all those terms, 56 times 243 times negative 8, that's equal to negative 108,864 x to the power of 5. And that's our solution for number 11. Number 12, find the coefficient a cubed b4 in the expansion of 5a plus b to the power of 7. Okay, so same deal as before. We got our 3 terms. It's to the power of 7, so that's going to be 7. Our first term is 5a. Our second term is simply b, right, just positive b. So, so what is the exponent over here? Since we want b to the power of 4, it's going to be 4, and this has to be 3 because 3 plus 4 is equal to 7, and that turns out exactly what we want. A cubed, b4, this is a cubed, this is b4, and this is going to be 4 as well, because that term over there, the number over there, is same as the exponent over there. So, what is this equal to? 7, choose 4, and that's equal to 35. 5 cubed is 125a cubed, and this is b to the power of 4, right? So that's 35 times 125, so that's 4375a cubed b4, and that's the value, that's the coefficient in front of that. So we're done with number 12. Let's move on to number 13. Find the coefficient a5, b7 in the expansion of that. Again, same old thing. We have 12 over there. Our first term is a. Our second term is b. We want this to be 5 because it's a to the power of 5 and b to the power of 7. So since that's 7, we know this is also 7. So literally we have to do 12, choose 7 on your calculator, and that's 792, A5, B7, and we're done. So we're done with number 13. Okay, let's do the next one. Now, all right, so number 14, let's work on it. So find the term in x to the power of 4 in the expansion of 3x squared minus 2x to the power of 5. So whenever you have a variable in both of them, in both terms, then this is probably one of the situations where you actually have to write a little table. So let's first write this as much as possible. So this is 5 over here, so 5 goes over there. This is 3x squared, and this is, oh, the first thing you should probably do is whenever you have a reciprocal function like that, you should probably write it as 3x squared minus 2 x to the power of negative 1, because 2 over x is simply x to the power of negative 1 to the power of 5. So what you can write here is x to the power of negative 1. All right, so the next thing we need to do is we need to figure out what these exponents will be such that we can end up with x to the power of 4. Okay, so this is probably the best time where we can write a table. So this is 3x squared, and this is x to negative 1. So if we have x to the negative 1, so let's start with 0 because our index usually starts at 0. So if we have 0 over there, that's going to be 0 there, and that's going to be 5 over there because 5 plus 0 has to equal 5. So in other words, if r equals 0, then you can see that x squared to the power of 5, so 2 times 5, this is going to be 10, whereas negative 1 times 0 is going to be 0. Now 10 plus 0 is not 4 as we want, so this doesn't work. Let's try r equals 1. Okay, so in other words, if we try r equals 1, then let me just erase these here. So if we try r equals 1, then this becomes 1, that becomes 1, and this becomes 4, because 4 plus 1 must equal 5. So if r equals 1, then this becomes 8, because 2 times 4 is 8, and negative 1 times 1 is negative 1. Now what's 8 plus negative 1? That's 7. That's close, but not really to what we want, right? Now, if you observe the pattern here, we don't have to keep sort of erasing and just doing it manually. Just observe the pattern. So if, over here, you can see this is 10, 8, it drops by 2. And over here, 0 to negative 1, it drops by negative 1. So you can confidently say that r equals 2 will pretty much be 10, 8. This will become 6 because it drops by 2. And this will become negative 2. And you can see that pattern going. So 6 plus negative 2, that's exactly equal to 4. So this is exactly what we want. So we want our r to be 2. So if this is going to be 2, that is going to be 2, and this is going to be 3. Because remember, 3 plus 2 must equal 5. So if I plug this into my calculator, 5 choose 2 is equal to 10. This is equal to 10. Now 3 cubed is 27, and x squared cubed is x to the power of 6. And finally, negative 1 times 2 is x to the negative 2. And what this is going to equal is 270 times, now x to the power of 6 plus negative 2 will be x to the power of 4, which is exactly what we want. So we want this to be 270, or we want this to be x to the power 4, and we get 270, and that's our answer. Okay, now because I sort of used up some space, I kind of need to erase this, so you can always scroll back and see how I did this problem, but our answer will be 270 x to the power of 4. So this is 270 x to the power of 4. Okay, so we're done with number 14. Let's do 15. So when the expression 2 plus ax to the power of 10x is expanded, the coefficient x cubed is 414720. Find the value of a. Okay, great. So same deal as always. Really, there's not much difference between these questions. So this is going to be to the power of 10, so this has to be 10. This first term is 2, and the second one is ax. Now, we want x cubed, right? So that means that the only variable here you see is the ax part. So this has to be 3, okay? And if this has to be 3, then this has to be 7, because 7 plus 3 must be 10. And if this last term has an exponent of 3, then that means that's over there as well. So let's expand this. So 10 choose 3 is equal to 120. So this is 120. 2 to the power of 7 is equal to 128. So it's 128. And ax cubed will actually mean 8 cubed times x cubed. Okay? So if we continue this, 120 times 128 is equal to 15360 a cubed x cubed. Now, what they said was the coefficient was 414720. So what that means is this expression part here, the stuff before the x cubed, is actually equal to 414720. So let me just do that. So I have 15360 a cubed is equal to 414720. So in other words, I need to find what a is, because that's what they asked for, to find a. So I should basically do a cubed is equal to 414720 divided by 15360. What do we get there? 414720 divided by 15360, and I get 27. I get 27. So a cubed is equal to 27. So a is the cube root of 27, and that is equal to 3. So the answer for this one is simply a equals 3. Okay, so we're done with 15. I just need to erase this because I need room for the other questions, but you can always scroll back and see how I did this problem. So in this case, a is equal to 3. Okay, so number 16. Expand x minus 2, 4 and simplify your result. So if we expand that, what we can do is simply, it's the easy way to do it. Okay, well, I'll just expand it the normal way. So it's equal to 4 choose 0, x to the power of 4, and negative 2 to the power of 0. The second term is 4 choose 1, x to the power of 4, and x to the power of 3, and negative 2 to the power of 1, plus 4 choose 2, x to the power, remember the powers are decreasing, so whereas the second term is increasing. So negative 2 to the power of 2, plus 4 choose 3, x to the power of 1, and negative 2 to the power of 3. And finally, the last one is 4 choose 4, x to the power of 0, and negative 2 to the power of 4. Okay? So what that equals is this first term is 1. This is x to the power of 4. And then negative 2, that's also equal to 1. So I'm just going to leave it like that. The second term is going to be plus, this is 4x cubed, and then this is negative 2 to the power of 1, so it's negative 2 right there. And the third term is going to be this one right here. I believe that's 6. 4 choose 2, yeah, that's 6. X squared times negative 2 squared is just simply 4. This one is 4 choose 3, so that's 4. This is x, and this is negative 2 cubed, which is basically equal to negative 8. And this last term here is 1 times x to the power of 0, which is also 1 times 16. So what this is equal to is x to the power of 4 plus, now this is 4 times negative 2, so it's negative 8. So maybe I should just erase that, right? Negative 8. So it's negative 8 x cubed. This one is 6 times 4, so that's plus 24x squared. This is 8 times 4, so it's negative 32x, and then plus 16, right? So the expansion of this is going to be x to the power of 4 minus 8x cubed plus 24x squared minus 32x plus 16. Okay, so I'm just going to erase all this because I need the space for part B. So that's basically, you can always scroll back in the video and figure out how I found this answer. So that is the solution for A. So let's do B. Find the term of x cubed in this expansion. So basically, we're just taking this first term over here and multiplying it by 3x plus 4. So if we have 3x plus 4 times x to the power of 4 minus 8x cubed plus 24x squared minus 32x plus 16. Now, the mistake in this question is, the temptation is obviously, is to maybe expand everything and just find out what the x cubed term is. But the smarter way of doing it is, you know that the 3x will multiply with each term, right? So just figure out the term that 3x needs to multiply by in order to get x cubed. So if this is 3x, it needs to multiply by 24x squared, because the x to the power of 1 times the x squared over there will give you cubed. So basically, we'll have some terms before, but then one of them will be 3x times 24x squared. 24x squared. If 3x multiplies with anything else, so say 3x multiplies x, this is x to the power of 5, this is x to the power of 4, this is x squared, and that's simply x. So we're only concerned with the x cubed term, so the smart way of doing it is just getting that. Now, so we're done with the 3x. Now let's get the 4. The 4 needs to multiply by the x cubed term because it's a constant times that. If you multiply by anything else, you won't get the x cubed term. So 4 times negative 8x cubed, so that's another term. So it's 4 times negative 8x cubed, right? We'll give you the cube term, and then we get everything else. And we really don't care about anything else because we're only interested in the x cubed term. So what this is simply 24 times 3. So that is 72. Yeah, so that's 72x cubed. And this is negative 32x cubed plus dot, 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 whatever that dot is, we don't really care. And if we just subtract these two, we will get 40. 72 minus 32. So that's equal to 40x cubed plus dot, dot, dot. So the term that we're concerned about is 40, and so find the term, and so we're done with this one. Right? So the answer here is 40x cubed. So I'm just going to erase this because I just need the space for everything else. But you can always scroll back in the video to see how I did that problem. So this is done, and so we're done with 16. Let's move on to 17. Expand 2x plus 4 to the power of 4 and simplify your result. So if you sort of look at the previous one was x minus 2 to the power of 4, and this is x plus 2. And really the only difference between these two is that the minus will sort of alternate the thing, whereas the plus just makes everything positive. So I could do the whole, 4 choose 0, 4 choose 1, 4 choose 2, and everything like that. But really, and if you do that, this is what you should get. You should get x to the power of 4 plus 8x cubed plus 24x squared plus 32x plus 16. Okay, and so that's how you do 17a. Okay, so now let's do this one. Hence, find the x squared term in this expansion. So remember, the first thing to do whenever you see a reciprocal is always sort of multiply it out. So we get 2 plus x to the power of 4 times 1 plus x to the negative 2. Okay, so just do that and that'll sort of make your life easier. So I'm just going to rearrange this. I'm going to say 1 plus x to the negative 2. And since we've already expanded this term, which is that over there, I'm just going to write that. So that's x to the power of 4 plus 8x cubed plus 24x squared plus 32x plus 16. Okay? So what we observe here is, remember, we're looking for the x squared term. So the smart thing to do is not to expand everything, but just look for how the first term over here will multiply with each of these terms. So just multiply it such that only figure out the term that where you get the x squared term. So 1 times the 24x squared will give you an x squared term. If you multiply with anything else, so say for example, you multiply the 1 with the 8x cubed, you'll get the x cubed term, which is not what we want. We just want the x squared term. So we're going to get a lot of values, but the one that we're interested in is 1 times 24x squared. So 1 times 24x squared, right? So we've dealt with that. And the second one we want to do is x to the negative 2 times, it's going to be x to the power of 4. Because negative 2 plus 4, remember the exponents add, negative 2 plus 4 will give you x squared. So it'll be x to the negative 2 times x to the power of 4. Right? So, and there'll be dot, 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 right? So, and so basically what we'll get is 24x squared plus x squared plus dot, 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 and we end up with 25x squared plus dot, dot, dot. So the only term that we're concerned about is really just this, the 25x squared, actually let me just circle the whole thing, is the 25x squared, and this is our solution for number 17, or number 17b. Okay. Moving on, 18, the fifth term in the expansion is given by 10 to the power, 10, 4. Now, it's important to, etc. So, why is the fifth term have a number of 4? Why isn't it 5? The reason why it's 4 and not 5, because remember, our index starts from 0. So, our first term is 0. Our second term has an R value of 1. Our third term has an R value of 2. Our fourth term has an R value of 3. And our fifth term has an R value of 4. So our fifth term has an R value of 4, and that is the reason why this is 4. Okay? So just to understand that a little bit, I'm just going to erase that. But that's the reason why this is 4. And remember, if this is 4, that last term is 4, and then this is 6, because 6 plus 4 has to equal 10. All right, so write the value of n. N is equal to 10, because that's basically the power. So n is equal to 10. So we're done with A. Write down the values of A and B in terms of P and Q. So basically, remember the first term, A, is basically what P is. So A is equal to P. It's as simple as that. And B is equal to simply the second term, so B is equal to 2Q. There's nothing really challenging or anything. It's just A is the first term over there, and B is the second term over there. I think I'm just going to erase it a little bit so there's some room, but A is over there and B is over there. Okay, good. Now, write down an expression for the sixth term of the expansion. So if it's the sixth term, right, remember, if it was the fifth term, we said 4. So if it's the sixth term, this must be 5, right? So it's 10, choose 5, okay? It's P to the power of something, and 2Q to the power of something. So if this is 5, that must be 5 as well, and that must be 5 as well. And write down an expression. They just said write down an expression. I don't know if they want us to evaluate it. Something tells me that this would just be a paper 1 question. And anyways, if this was a paper 1 question, you just simply have to write this down, because they just said write an expression, and this is the expression itself. I doubt they would make you sort of evaluate what 10 choose 5 is. You don't really need to do that. I don't think so, because then you have to do 2 to the power of 5 times that. It's sort of a hassle. So anyways, I think if you did this, you would have pretty much gotten all 3 marks. All right, so number 19 is a little bit of a tricky one, because it combines binomial expansion with the derivatives. So anyways, let's just start with number 19a, expand that. So you can see that this is a 1x over here, and this is a 1h. So instead of doing, 3 choose 0, x to the power of 3, and all that, like just the way we've been doing it, we can simply use Pascal's triangle. So actually, let me just use a black one. So I have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And I'm stopping at 3 because it's x to the power of 3. So this is equal to x cubed plus 3x squared h. Let me just erase that so I have it a bit more neat. So that's x cubed plus, see this term here, that's going to be 3. And you can observe that the powers of x must decrease, while the powers of h must increase. So that's 3x squared. And then the next one is going to be 3xh squared. X decreases by 1 and h increases by 1. And finally, and that's this 3 here, that's how we get that 3. And finally it's 1, so it's going to be x is going to be x to the power of 0, and so it's going to be h cubed. And so that is the expansion of this. So if you're showing this, you can do it, the normal way, which is using the combinations. But if you show the Pascal's triangle and show this sort of together, you'll get full marks either way. So what I'm going to do is I'm just going to erase this part because I need room for part B and so on. Okay, so part B. Use the formula this is the definition of the derivative, to show that the derivative of f of x is 3x squared minus 4. So it's sort of going to be a lengthy process, so I'm going to show it this way. So f prime of x, so it's going to be the limit as h goes to 0. And so this is f of x plus h. So in other words, what we're going to do is for each of the x's, we're going to put x plus h. So I'm just going to put a bracket here to represent x plus h. So it's going to be x plus h cubed minus 4 times x plus h plus 1. And that's going to be subtracted from simply f of x, which is x cubed minus 4x plus 1. And this is all over h. Okay, so let me do this. So h goes to 0. So we need to expand this, but we already have that expansion over there, so I'm just going to use that. So that's going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. So that's just the expansion of this. Minus, this is going to be 4x minus 4h, and it's going to be plus 1. Okay. Now, I'm just going to remove these brackets, so actually really I don't even need this first bracket right here. So I'm going to remove these, so it's going to be minus x cubed plus 4x minus 1. And this is going to be all over h. Okay? So you just have to be very, very careful when you're expanding and multiplying and treating negatives because it becomes very, very sensitive. So anyways, let's start canceling some terms. So we see an x cubed here, and we see a negative x cubed there, so we can cancel these two terms out. I see a negative 4x and a positive 4x, so I can cancel those two out. I can see plus 1 and minus 1, so I can cancel those two out. And that's it. That's all I can cancel out. Now, the important thing over here is when you're doing the limit as h equals 0, anything divided by 0 is undefined. So what we need to do is somehow get rid of that h. So if you observe, the only terms left, the 3x square h, the 3x, etc., each of them have an h in them. So what we can do is we can factor out an h to help us with our cancellation. So we have h, so what we're left with is simply 3x squared. This is going to be plus 3xh, because if we factor that out, this is going to be plus h squared, and this is going to be minus 4, right? And it's all over h. So if we do that, we cancel this h and we cancel that h out. So what are we left with? We're still left with that limit. We're still left with that limit as h goes to 0. So it's going to be 3x squared plus 3x to the power of h plus h squared minus 4. Now as h goes to 0, basically this will go to 0, and so will this, because as h goes to 0. So what are we left with? So all we're left with is simply 3x squared minus 4. And if you read the question again, so we've sort of covered it, but you'll see that says 3x squared minus 4, which is exactly what we have over here. Okay? So what I'm going to do right now is I just need some space to do the rest of the question, so I'm going to erase this. But feel free to scroll back to the video, on the video, and figure out how I basically got that solution, and then you can see that. So let me just scroll up here. So I'm just going to erase that. So basically we've shown that it's 3x squared minus 4, so that has been done. The tangent to the curve of f at point P, 1, negative 1, is parallel to the tangent at point Q. Find the coordinates of Q. So if something is parallel, it means it has the same slope. So first let's find the tangent. The tangent just means the slope. So this is the derivative, so let's find the slope. So f prime of x is simply 3x squared minus 4. So if we want to find the slope, we just have to plug in the f point, the x point. So it's f prime of 1 is 1 squared minus 4. So that's equal to 3 minus 4, which is equal to negative 1. So the slope is equal to negative 1. So we need to find another point is parallel to the tangent at... okay, so we basically... Hold on. The tangent of the curve of the point is P negative 1, and it's parallel to the tangent at point Q. So that means the slope at this point, which is negative 1, is also the slope at point Q. So what we need is, we need to figure out the other sort of point where we need to find the coordinates of Q. So in order to do that, we know that f prime of x is equal to negative 1. So we know that the slopes of P and Q are going to be the same. So we need to figure out the other point where we can get the same slope. So since this is equal to negative 1, it's going to equal to 3x squared minus 4, because this is the derivative, and we want to make sure that this derivative is equal to negative 1. So we have to find the other point of x. So since that's equal to each other, so 0 is equal to 3x squared. We're going to add 1 to both sides, so it's going to be minus 3. And, okay, so I guess I want to isolate the x squared, so I can add 3 to that side. So 3 is equal to 3x squared. We're going to divide by 3, so 1 equals x squared. So what this means is x equals 1, or x equals negative 1. We know that x equals 1 is a solution because we have this point over here, x is equal to 1. But we need to find the coordinate, we need to find, because it said find the coordinates of Q, we need to find the other coordinate of x equals negative 1. And in order to do that, we're not going to plug it into 3x squared minus 4 because that's the derivative function. If we want to find the coordinates, we have to go plug it into the original function. The original function is x cubed minus 4x plus 1. So what we have to do is we have to plug this into f of x, which is x cubed minus 4x plus 1. So that's going to be negative 1 cubed minus 4 times negative 1 plus 1. So negative 1 cubed is negative 1. Negative 4 times negative 1 is plus 4 plus 1. These two cancel out, and so you get 4. So the coordinate of the second point, the coordinate of Q, I'm just going to write that here. The coordinate of Q is now negative 1, because that's the x, and the y is 4. So we have Q. Again, I'm just going to erase this, and because I need room to sort of do the rest of the questions, so I'm going to erase this right there. Okay, so that's Q. All right, so we got C, let's do D. The graph of f is decreasing for P between P and Q. Find the value of P and Q. Okay, so if a function is decreasing, what it means is its slope is sort of decreasing. So in other words, its slope is negative. That's what it means. Okay, because there's no other way of having a function that way. Oops, my thing is frozen. Oh, here we go. That's the issue. It just wasn't working for a second. So anyways, so if we have a function that's decreasing, what it means is like its function probably looks like this, and it's going down. So it's decreasing. So in other words, this point is P, and this point is Q, and they want to find out that region where it's decreasing. So if it's decreasing, what it means is its slope is negative, because the only way it can decrease is if its slope is negative. So what that means is this is where 3x squared minus 4 is less than 0. Okay, so a good way sort of at looking at this, if 3x squared minus 4, where that is negative, is let's draw a little graph of it. So this is a derivative function. 3x squared minus 4, what its graph looks like is something like this, where its vertex point is at negative 4. So it's going to be negative from here to here because it's underneath the curve, right? It's underneath the x-axis. So we need to find what this point is. That's going to be your P point. And you need to find what that point is, and that's going to be your Q point. So what we need to do is just basically set this to 0 and figure out what P and Q are. So it's going to be 3x squared minus 4 equals 0. So 3x squared is equal to 4. So x squared is equal to 4 over 3. So x is simply equal to the plus minus the square root of 4 over 3, which is basically equal to the plus minus 2 over root 3. So the p-value is going to be the smaller value. So the smaller value in this case is going to be negative 2 over root 3. So this point over here, and maybe just use a different color. So this point over here is going to be negative 2 over root of 3. And the higher value is going to be right there. And so that point is going to be positive 2 over root of 3. Okay? So if we want to find what the p and q values are, it's just basically draw the curve of the derivative. You want to find the parts where the derivative is going to be negative, and that's obviously between p and q. And simply find the roots, which we found over here, which is 2 over root 3, and there you go. So what I'm just going to do, I'm just going to erase this. Remember, you can always scroll back and figure out how I've done that. But the solution here is negative 2 over root of 3 x all the way to 2 over root of 3. Okay, so write down the range of values for the gradient of f. Okay, so once again, we could have just left that graph, but anyways, I'll just draw that again. So the graph is like this, and remember, this is the, maybe I should draw in a different color, but here's this graph, okay, and this is the f prime graph. So the range of values for the gradient just means slope. So in other words, this is at negative 4. So the range of values is everything above negative 4. So the gradient of f, let me just put blue here. So the gradient of f, in other words, f prime of x is simply greater or equal to negative 4. The lowest it can be is negative 4, and it can only just go up from there. So that's the solution for E. Okay. All right, so that was number 19. I think we just have a few more questions to go, and then we should be done with this. All right, so number 20. Let's do number 20. So expand e plus 1 over e to the power of 4. So the way I'm going to do this is always write it this way. So e plus e to the negative 1 to the power of 4. So because these are, okay, so what I can do is, I'll just do it the normal way, so which is 4 choose 0, e to the power of 4, and then e to the negative 1 to the power of 0, plus 4 choose 1, e to the power of 3, e to the negative 1 to the power of 1, plus 4 choose 2, e to the power of 2, e to the negative 1 to the power of 2, plus 4 choose 3, e to the power of 1, and e to the negative 1 to the power of 3, and finally 4 choose 4, e to the power of 0, and e to the negative 1 to the power of 4. Okay, so what that is equal to, the first term, this is 1, this is going to be 1, and this is e to the 4, so this is simply e to the 4. This is going to be 4, this is going to be e to the negative 1, 3 plus e to the 3 plus negative 1 is going to be squared, so it's going to be 4e squared. This one is going to be 6, so this is going to be plus 6, because 4 choose 2 is 6. This is going to be e squared, and this is going to be e to the negative 2. So e squared, so in other words, 2 plus negative 2 is going to be 0, so it's just going to be 6. And so what you can notice over here is this is going to be 4, this is e to the 1, and this is going to be e to the negative 3. So 1 plus negative 3 is negative 2. So it's going to be e to the negative 2. And our last term, 4 choose 4, is 1. This is e to the 0, and this is e to the negative 4. So it's going to be e to the negative 4. So the solution to this one, so I'm just going to erase this just because I need room, but the solution to this question over here, is equal to e to the 4 plus 4e squared plus 6 plus 4e to the negative 2 plus e to the negative 4. Okay, and I'm just going to erase this part, so I don't need that. Okay, so that's the solution for this one. And you can remember, you can always scroll back to see how you can have done that. Now, express e plus 1 over e to the power 4 plus e minus e to the power 4 as a sum. Okay, so there's a little trick to this. So the point is, the first term is, we've already determined that. That's going to be e to the power 4 plus 4e squared plus 6 plus 4e to the negative 2 plus e to the negative 4. Okay, so that's the first term. And so what we're going to add it is, this is e minus 1 over e. So in other words, this is very similar to the first one, except there's a little negative. And what that negative does, it's sort of, for the middle terms, for alternate terms, it just makes them into negative. So really, without even having to expand this on our own, we already know the solution. It's e to the power 4 minus 4e squared plus 6 minus 4e to the negative 2, and then plus e to the negative 4. And we know that it's minus because if we look at the second term would be 4 choose 1, and the term itself is negative. So basically it would be something like negative e to the negative 1 to the power of 1. So because it's an odd power, this ends up being negative, which makes this negative. Like this, let me just write that term. So if I wrote that term out, so if I wrote this term out, it would simply be 4 choose 1. It would be e to the power of 3, and it would be e to the, it would be negative e to the negative 1 to the power of 1. So everything would have basically been, and it would, this is 4, this is equal to 4, this is e, and this is negative e to the negative 1. So in other words, this would simply be negative 4e to the 2, right? Which is basically what we got there. So, but if it was, say, for example, an odd power, or sorry, an even power, then that's why this becomes positive. So we don't have to worry for these ones, but it's only when like this power is 1 or an odd power, which is why we have to worry about that. So let me just erase this, so just to prevent any confusion. Right? So that's why. So whenever you have a minus, just remember that the alternate terms become negative. So if we're adding these two up, we can clearly see that these sort of will cancel out, these will cancel out, these will cancel out, and these will double. So this becomes 2e to the power of 4, this will become 12, and this will become plus 2e to the negative 4. And that's our solution. Okay, I think we have like 4 more problems left, and then we're done. Okay, so given that 3 plus root of 7 cubed is equal to p plus q root 7, where p and q are integers, find p and q. Okay, so we could do this the binomial expansion way, but there is a faster way, and because it's cube, I'm just going to deal with it just through regular expansion, how we would do regular expansion. So this is 3 plus root of 7 to the power of 3, which is the same thing as saying 3 plus root of 7 times 3 plus root of 7, and I'm just going to square this. So I'm going to square, so this cube is really, I'm displaying to 1 over here and 2 over here. So I'm going to expand this one, and then I'm going to multiply it out there. So this is going to be 3 plus root of 7. And this is going to be, if I cube this, or square that, that's going to be 9 plus 6 root 7 plus 7, right? So I'm just sort of doing this in my head, but you can expand it out and do it your way too. But I just prefer this way. So in other words, if you square that, that's what you get. So I'm just going to simplify that just before I do the last expansion. So 9 plus 7 is 16. So 16 plus 6 root 7. Okay. Now I can expand this over here. So 3 times 16 is 48. 3 times 6 root 7 is equal to plus 18 root 7. Root 7 times 16 is equal to plus 16 root 7. And finally, root 7 times 6 root 7 is going to be 6 times 7. That's going to be plus 42. And all we have to do now is just combine the like terms. So that's going to be 90. So that's going to be 90. And this is going to be 30, wait. Yeah, 34. Let me just double check that. 8 plus 6 is 14. Yeah, okay, it's going to be 34 root 7, right? So if we look at this, it's p plus q root 7, so p must be 90. P must be 90, and q must be equal to 34. And that's it. You could have done this through, you know, the binomial expansion, everything that we've learned, but I personally think that this is a faster way just because that was cubed and it just made it easier to do that. If it was 4 or 5 or to the power of 6, I would have done something different. I would have just used binomial expansion, but because it wasn't that, I just made my life easier by doing this. And once again, you can always scroll back and figure out how we sort of solve that. Okay, so I think it's the last 2 questions, or no, last 3. Okay, so we're almost there, guys. All right, so let's do this. Consider the binomial expansion of 1 plus x4, so they've done that for us. By substituting x equals 1 or otherwise, evaluate 4 choose 1 plus 4 choose 2 plus 4 choose 3. Okay, so if you think about it, the fast way to do this is 1 plus x to the power 4. So they're saying substituting x equals 1. So really, if we look at this, this is simply, if I substitute, this is simply 1 plus x to the power of 4 minus the first term minus the last term, right? This is 1 plus x to the power of 4 minus the first term, which is 1, minus the last term, which is x to the power of 4, right? Because it's just literally these 3 terms, and since x is equal to 1, this will be 1, that'll be 1, that'll be 1, which is what we have over here, right? And these 2 other terms are lingering, so if I subtract them and move them to the other side, this is what I get, right? And now we know that x is equal to 1, so let's just substitute x equals 1. So this is 1 plus 1 to the power of 4 minus 1 minus 1. So it's equal to 2 to the power of 4 minus 2. 2 to the power of 4 is 16, so 16 minus 2, so that's equal to 14. So the answer to this is simply 14. We could have plugged it in, but I'm assuming that this is actually a paper 1 question, so if it was a paper 1 question, you probably couldn't have plugged that in. But anyways, that's kind of the simple way to do it. If it's a paper 2 question, then you could have just plugged that in and it would have been as easy as that. Okay, so if we use this concept, right, basically now they said evaluate this. So if we use the same concept, right, regardless of whether it's 1, 2, or 4, like there would have been a 1 over here, like there would have been an x over here, like basically this would have been x to the power of 9, then x to the power of 8, x to the power of 7. But if we substitute x equals 1, they all are just simply 1, 1, 1, 1, 1, 1, 1, right? And again, this is equal to basically the very same form, but instead of 4, now we have 1 plus x to the power of 9, and our first term will still be 1 because, sorry, where is it? Yeah, our first term will still be 1 because it's 1 plus x, so we can just subtract that, and the last term will be x to the power of 9. Now if we substitute x equals 1, this will be 2 to the power of 9 minus 1 minus 1, so it's 2 to the power of 9 minus 2. I actually don't know what 2 to the power of 9 is, so let me just figure that out. So 2 to the power of 9 is 512. That's 512 minus 2, and that's equal to 510. So basically, the point of A is to sort of give you a hint of how to do B. And if you can see the same form, then you can do B. So this is equal to 510. So I'm just going to erase this because, once again, I need room. But remember, you can always scroll back and see how we basically did this problem. So, and this was 14. Okay. All right, last two problems. Consider how many terms are there in this expansion. There are going to be 10, because if that's to the power of 9, this is going to be 10. Find the constant term in this expansion. So classic problem that we've done before. So we're just going to do this, this, and this. This is going to be to the power of 9. This is going to be 3x squared. That's going to be negative x to the negative 1. Remember, try to write it as a reciprocal. Now, this is the classic problem where we need a table. So I'm just going to sort of write a table out. This is going to be 3x squared. This is going to be negative x to the negative 1. Okay? And once again, if we're going to start with r equals 0. So if this is 0, that's going to be 0, and that's going to be 9. So that's going to be 2 times 9, that's 18, that's 0. And 18 plus, and we're looking for the constant terms. In other words, these two have to add up to 0. And this definitely does not add up to 0. So let's do r equals 1. If we do r equals 1, so I erase that, I erase that, I erase that. We do r equals 1. So then this becomes 1, and then this becomes 8. So this is x squared, so it's 2 times 8, so it becomes 16. And this becomes negative 1 times 1, so it becomes negative 1. And 16 plus negative 1 is not 0, so we cancel that out. So observe the pattern over here. This is decreasing by 2 each time, and this is decreasing by 1. So if I go r equals 2, I know the next one will be 14, without even having to put it in here. I know the next one will be 14, and this will be negative 2. That does not work, because 14 plus negative 2 is not 0. R equals 3. This is going to be 12, and that's going to be negative 3. Again, that does not work. R equals 4. It's going to be 10. That's going to be negative 4. Does not work. R equals 5. That's going to be 8. And this is going to be negative 5. Does not work. Because remember, we want a constant term. So these two have to be sort of negatives of each other. So R equals 6. This is going to be 6. And this is going to be negative 6. Boom. This works. So R equals 6 works. And we'll see how that works in a second over here. So if this is R equals 6, if this is r equals 6, then this must be 6, and this must be 3, right? Because 3 plus 6 must be equal to 9. So 2 times 3 is 6. Negative 1 times 6 is negative 6. So this is our solution. So 9 choose 6. We have to go there. 9, I'm just plugging this into a calculator. So 9 choose 6 is 84. Is 84. 3x, so this is equal to 27x to the power of 6. And this is equal to negative x to the power of negative 6, right? And, oh, actually, and it's going to be positive. It's going to be positive because it's to the power of 6, so it has to be positive. Anything to an even power will always make something negative into positive. So that's 84 times 27, and what that is equal to 2268. So this is 2268, and this is going to be x to the power of 0, which we don't have to even write because that's equal to 1. So this is our solution. Okay, so I'm just going to erase this, and I'm going to say this is 2268. 2268. You can always scroll back and see how I did that. Did this table basically. So the answer here is 2268. All right. So our last question of the evening or the day or whatever time you're seeing this is x plus x minus 2 over x squared, 9. So this is basically equal to x minus 2, x to the negative 2 to the power of 9. Okay, so we want the constant term. So this is definitely going to be a table because our first term is a variable and our second term is a variable. So let's do number 24. This is going to be just like always. We have 3 terms here. This is going to be 9 because that's the power of 9. This is going to be x. And this is going to be negative 2x to the negative 2. Okay, so we need to find different powers such that it ends up getting our constant term. So what we're going to do is we're going to write our little table. So this is x, and this is negative 2x to the negative 2. So let's pick r equals 0. So let's pick r equals 0. So know that if this is 0, that's 0, and then that will be 9, because 9 plus 0 must be 9. So the first term will be 9. and the second term will be negative 2 times 0 is 0. So 9 plus 0 is not 0. So because we want a constant term, we want these exponents to be the same, but negatives of each other. Let's do r equals 1. In other words, oops, I got a little too eager there. So that's going to be 1, this is going to be 1, and that's going to be 8. So this is x to the power of 8, so this is 8, and this is negative 2 times 1 is negative 2. So 8 plus negative 2 is 6, which is not what we want. Now, we don't have to keep writing these down each time because we can see the pattern. The pattern is this drops by 1, and this drops by 2 each time. So the next number will be 7, and this will be negative 4. 7 plus negative 4 is 3, which is not what we want. Let's do r equals 3. We know it's going to drop by 1, so this is going to be 6. This is going to be negative 6, and boom, it drops by 2. So this is exactly what we want. We want r equals 3. So if we switch this is going to be, this is going to be r equals 3. So that's going to be 3, and that's going to be 6, because 6 plus 3 must equal 9. So if I do this here, 9 choose 3 is 84. Okay, that's x to the power of 6, and this is negative 2 cubed, which is going to be negative 8, and this is x squared, so this is going to be x to the negative 6, and so our solution is 84 times negative 8, which is negative 672, and this is going to be x to the power of 6 times x to the negative 6, and these two will add up to 0, and x to the power of 0 is 1, so we don't even need to write them at all. So they go away. So our constant term, because that's what we're looking for, is negative 672. And now we're finally done with the binomial package. All right, I'll see you for the next review package. All right, take care and see you in class. Bye.